Dr. Faeza Hafiz completed her BSc Engineering from University of Engineering Technology as well. And then she went to North Carolina State University to complete her PhD. And she is currently working in the Hitachi ABB Power Grid Research USA. And actually today we had 4 people on the event banner, and all of the 3 speakers live in separate time zones. Although Dr. Faeza and Dr. Shamima are both from US, Dr. Shamima was from West Coast, and Dr. Faeza is from the East Coast. So, and she's also an expert in power systems. So, which is we're really glad to hear from her today. And with this, I would like to invite Dr. Faeza Hafiz to share her talk.
So yeah, Sajid already introduced me. I completed my PhD back in 2018. During my PhD, I had experience to work in National Renewable Energy Lab and Argonne National Lab in USA. After PhD, I joined at ABB Corporate Research Center, and the power grid part of ABB Corporate Research Center is is owned by Hitachi right now. So right now I'm currently working at Hitachi ABB Power Grid Research Center. My research interest includes optimization, mathematical modeling, power system, machine learning and data analytics, and integration of different devices in the power system. So let's go directly to the talk. So when we are talking about power system, basically there are 4 different levels in power system, like transmission, distribution, generation, and customer level. So typically when we think about generation system, currently the basic picture comes in our mind is like very huge power plants like hydropower plants that we have seen in Kaptai back in Bangladesh, or in Meghnaghat we have different kind of combined cycle power plants. That is the current scenario in our power system we are seeing, but basically as there is a requirement to deploy renewable energy resources as we want to go for greener energy, so we can see there is the larger power plants are getting replaced by small different renewable energy resources. That is the future generation side. We can see that in future we'll see a different kind of renewable energy resources. On the transmission side, right now we can see a lot of power lines, like huge power lines which is going for miles and miles. But in future, we are predicting that these transmission lines will be going for small scale transmission system, including different kind of protective devices. So when we are talking about the distribution system, actually we are seeing a huge change in distribution system. So basically our existing distribution system is planned as a unidirectional power flow. So what does this unidirectional means? Like basically from generation to transmission to distribution, and from distribution to customer, like your home level, the power is flowing in one directional way. But in future, due to the deployment of solar panels in our houses, we are going to see that this power direction is not unidirectional anymore. It will change into bidirectional way. So that means there will be the generation can be from distribution side, and it can give power back to the grid. On the customer level, basically right now, till now, we are only the passive user. Most of us are the passive user of the power of electricity. That means we are only purchasing electricity from utility services. But in future, as we are deploying solar panels in our houses, we are going to participate directly in the electricity market, because if we have excess amount of solar generation, we can give power back to the grid and sell it to the market. So in customer level, that is also a huge change we are seeing. So this kind of change on different levels of power system requires to integrate in the current existing system very smoothly. But our existing power system is not in that situation right now to integrate these changes. So this is actually bringing the concept of smart grid. So in smart grid, actually, we are having a lot of smart meters and measurement system, including different kind of energy efficient resources that we want to use. So in smart grid, actually in generation side, as I already told before, that in a generation side, we are seeing a lot of renewable energy resources integration, as well as there's a new resources we are also seeing in the storage plant, inclusion in the smart grid. So in the generation side, when we are trying to include this kind of renewable energy resources, one important challenges we are facing that these renewable resources are not fixed resources. So when you are going to integrate into the system, a lot of challenges due to this uncertainty of this renewable generation you will face. A lot of research is going on in these areas, especially in power electronics areas and control system areas. So that's one part. So my background is not in power electronics, so I'm not going into that direction. There is in the distribution and transmission system, basically a lot of protective devices are coming right now, like STATCOM or phase measurement units we are seeing. So a lot of research are going on to that area as well. One important big area for research in distribution system is the inclusion of microgrid. So in microgrid, basically it has the ability to operate by integrating into the system in the grid directly, or you can control your get separated out from the grid and control your resources as like loads and generation in the system. And there are a lot of research are also going on in the controlling of the microgrid, as well as going for protection in the microgrid system. So if we come to the customer level, there are a lot of changes we are seeing in the customer level. Basically, electric vehicle is one of the important load right now we are seeing in this customer level, especially in US or European countries. And another important load right now we are seeing is data centers that just Shamima was talking about. So when this kind of loads are integrated in the power system, they are changing the power system pattern, load pattern a lot, and that's the situation where utilities are facing a lot of challenges. Utilities right now also considering to develop smart cities where there will be smart meters, as I said before, and smart devices. On the household level, there is deployment of smart houses. So smart houses has a energy management solution inside the smart houses to make the houses energy efficient. Sometimes it is called net zero energy or net carbon emission energy resources and these kind of new things are coming to the smart grid to make the smart grid reliable, flexible, and efficient. So as my today's talk is about basically optimization application on power system in smart grid, so I will focus not all of these areas. So I will focus the impact of optimizations in different areas of power system. So before going into that, I'll just give you a small example where optimization you can use in your houses. So suppose you have a solar panel in your house, you have excess, you have solar generators. So what happens in case of solar panels in your house? So definitely, as it's a solar generation, so you will have solar generation during the daytime. But in typical houses, we have seen that during the daytime, the house owners or everyone leaves house for their schools or offices. So what happens there? Your load demand becomes lower than your generation. So if you have excess amount of solar generation and you are not there to use it, then what will happen to it? You are going to lose it. So one solution is that you can use energy storage, and these days the energy storage unit cost is getting reduced. So you can deploy easily an energy storage in your house to capture that excess generation of solar to use it later. But when you are deploying this energy storage, then one question comes into your mind, that whether can I control this energy storage? So for basically charge controller for energy storage comes into the scenario at that point. But when you are going to design the charge controller, what will be your objective of the controller? Why it will control the energy storage charge? That is the one question to you. So as a customer, your objective might be to reduce your electricity bill. So that is the basic objective of the customers that we have seen. So basically, that's why the charge controller is specially developing in such a way to reduce your electricity purchase cost. In this case, the charge controller, the input to the charge controller will be how much solar generation you have, what is your electricity price, and what is your load demand. Then these inputs are actually going into the controller input, and then the controller, you have to give an objective to the controller. The objective is right now in current case, like we want to reduce our electricity purchase cost. So from mathematical modeling of this optimization objective, considering different types of constraint, we can formulate a problem which is called optimization problem for this energy storage. And after solving the problem, actually we'll get the output, like how much solar generation you are going to use, what will be your storage charging or discharging level, whether you want to use the storage right now or use it later, and how much electricity you are going to purchase from grid. So that is one kind of controller we are seeing in the household level for energy storage. But if you replace this storage with electric vehicles, what will happen? So electric vehicles has one important feature, that it has bidirectional capabilities. That means it can act as a generator as well as a load. So when you are integrating the plug-in electric vehicles in your house, it can not only get charged, it can also discharge when you require. And you can, the same way, you can actually design a controller for electric vehicle to get that how much to reduce your electricity bills, and you can utilize the stored energy from plug-in electric vehicles as well to mitigate your load demand. So that's one very example of optimization in home energy management solution. So what other aspect in the household level we can consider to utilize optimization? So in the aspect of energy, actually we can have different kind of loads, controllable loads like washer dryer, or plug-in electric vehicles, or storage, solar generation, and we can control them in coordinated way to basically to get some different kind of benefits. So when you are in customer side, you want to get your benefit definitely, and you can actually design your controller. Suppose you to reduce not only to reduce electricity bill, but also you can participate in transactive energy. Suppose you have power outage, so and you want to reduce your power outage hour, you can control your loads as well as the storage according to that, or you can be an independent energy user. On the utility side, actually utility can also control your loads. Basically what utility is doing, the curve just a while ago I showed you, that you might in the daytime you will have a huge amount of solar generation which is excess, and your load becomes lower at that time. What is right now California utility is system is facing, like they have a lot of solar deployment in their utility side, customer sides. So as a result, during the daytime, their load is getting very low. But at the night time, when people are coming back to the home and there is no solar generation, there is sudden ramp up of the electricity demand. So it's an issue for California, and right now they are actually trying to get rid of this problem by giving some reward to the houses to do the load regulation at the houses. So load regulation is basically saying that to maintain average load profiles or in the houses by controlling your loads. So utility through the demand response, they can send signals to the houses, and house owners can control their loads and the storage to do this load regulation or to give utility some kind of benefits to get some reward from utility. Like utility can consider getting the benefits by controlling the loads in load regulation, reliability, or if they want to reduce the backfeed of power, or like if they want to get rid of the asset replacement or to maintain power quality. Basically, all of these problems on the utility side is also some kind of optimization problem they need to solve. So basically, that's the optimization scenarios you can see in the household level. So let's go to the bigger picture in distribution and transmission system. So in distribution and transmission system, there are a lot of application of optimization and a lot of research are going on these areas. So in distribution system, like in USA, the power distribution system are not balanced. So here you can see on the right side of the picture that I have shown a smaller picture of distribution system. In distribution system, there are feeders, there are microgrids, and you can see there are some switches over there. So these switches can change the network power flow and network topology. And utilities changes these switches based on different to achieve different objective. So that's why network reconfiguration is an optimization problem for utility, and to change the direction of the power flow for different kind of for achieving different kind of objectives. Another important application of optimization currently people are using is the optimal planning of different devices or different resources. So suppose you want to deploy a charging station to a grid. So where you will deploy, what will be the best location for the deployment to get some kind of advantages or to give some auxiliary service to the power system. So that's the scenario where optimization is coming to plan the charging station. Similarly, if you want to deploy an energy storage in your distribution system, so where is the place you want to put it? That's one question to you. So by formulating this distribution system in an optimization problem to get different kind of objective, you can solve it. Distribution energy management is another kind of application. It's right now used by different distributed distribution systems. Basically, this objective of this distribution energy management is to reduce your economic cost by managing the loads that I am showing here in the distribution system. There might be some smaller distributed energy resources like DGs, PVs, or battery energy storage, or controllable loads. So you can manage this distribute these resources like changing the active and reactive power set points of the resources, or changing the loads. You can reduce your electricity purchase cost of the overall distribution system. So that's one aspect of distributed energy distribution energy management. In service restoration, actually, I worked during my internship with Argonne National Lab. I work directly with service restoration. So what happens in the distribution system is that when you are facing some natural disaster, or like here we see in US, in North Carolina, we see some storms or cyclones are coming, and during that time our due to some uprooted trees, we see that we are out of power for a longer time. So how can we overcome it? How can you reduce your power outage time period by checking the different resources in the distribution system and plan in an optimized way? That is a very big areas of optimization. So Volver optimization, that is another application which is right now utilities are using. So basically in Volver optimization, what utilities are doing, they try to control the reactive power control devices like capacitor banks or online tap changer in the distribution system to reduce the power loss in the power loss. So and this is actively this is a very active area of research due to the new energy resources are coming. When these new energy resources like distributed energy resources are coming, they have the inverters of this distributed energy resources have some capability of reactive power injection. Basically in the Volver optimization problem, previously online tap changer or capacitor banks were considered, but right now you can consider this a capacity of inverters, smart inverters, to get rid of the problem of voltage violation or reduce the power loss in the distribution system. So, and one part, I told before, that microgrid is also a huge area, and in microgrid there are a lot of application of optimization, like economic dispatch on the microgrid, when they are connected to the grid, or when they are connected to the islanding scenarios, and to maintain the voltage along the microgrid and the point where microgrid is connected, which is called point of common coupling. So these are the very big areas where the current research are going on. And the transmission side, one application of optimization right now is to get rid of the congestion problem in the transmission system by controlling the local marginal price in the generators. So these are the areas. Basically right now there are a lot of active research are going on, and some of the researchers outcome of the research are right now applied in the industry as well. So let's next go to the generation side. The application of optimization in generation side is in the electricity market. Basically, there in the electricity market, two kind of problems are solved. One problem is unit commitment problem. What is this unit commitment problem means? Like when you are in the generation system, lot of generators are coming into the system, and they are saying that I can sell you power at this unit price. Like diesel generators have some unit cost, or some combined cycle power plant might have some unit cost. So when they are saying that, then what is the objective of the utility? They have to purchase power in an optimized way by considering different constraints in the system. So that is actually a unit commitment problem. And it is basically an optimization problem that the utilities or different software solutions are selling this kind of objective to the utilities right now. Economic dispatch is also another kind of optimization problem, where basically when you are after you purchasing the unit commitment problem, actually this is a day ahead problem, optimization problem. Then next come to the question that how you will schedule these units during the daytime, in particularly in hour level or in 20-hour level or minute level. So there comes the economic dispatch problem, which is optimization problem. So basically this unit commitment problem and economic dispatch problem, they are already defined mostly by, recently there are some constraints like security constraint are considered, and there are active research going on this constraint. But one important thing is that in the distribution system or in the generation system, we have seen that when we are going to solve this unit commitment problem, there are more than 50,000 variables you have to deal with, more than 60,000 constants you have to deal with. And that's why you need more computational resources. So there is a very active research, like I was involved some kind of active research like this, like how can you make your optimization problem more computationally efficient so that you can solve this problem with less time. So basically, currently utilities are solving this problem. It takes more than 4 hours to solve for a high performance computer. But can you reduce the time like 1 hour or less than that? So there's a research is going on. Another, in the generation side, the centralized control and distributed control is another important area. So basically what happens in the generation side, when you are going to integrate your distributed energy resources, you can face some kind of problem like cybersecurity problem. In that case, or there might not be enough control from the main control system, like enough kind of communication that you required. So in that case, you can consider go from centralized control mode to the distributed control mode of the generator. So that's the active areas in the generation side. Next, I'm coming to the one important part of the that is where optimization is applied directly. That is cybersecurity in the power system. So when I was talking about this unit commitment, economic dispatch, microgrid, network reconfiguration in different levels, even customer level, the controlling the loads, all of these aspects require communication to this system, to these different levels in the SCADA system. What happens over there, like when you are communicating, there might be some attack or threat might come into the system that might give you wrong data, and that is called bad data or false data injection. And in the utility, in the SCADA side, they always check the state estimation, which is basically that optimization problem. By doing this state estimation, utilities can check that whether there is false data injection or not, to apply if you have some false data in the system, then you can replace that data by doing the optimal state estimation. So that's one important active research areas I said in different aspects. So basically, I want to go into a little different areas where optimization is applied, not directly, but inside of it. So that is the application of AI in a smart grid. Basically, when we are considering optimize AI, in AI, basically, we are solving an optimization problem to minimize a loss function. And in smart grid, and as we all of us know that AI is basically based on data, big data. So in smart grid, we are seeing a lot of smart devices from where you can get an explosion of data, like from the SCADA or advanced metering infrastructure, phase measurement unit, or different kind of intelligent electronic devices, or for weather, because weather also changes your renewable energy resource generation as well as the load. So this kind of data is like giving you a lot of insight of the power system analytics. So basically in power system, there are two kind of application we are seeing right now of data of AI. So one part is like power system analytics area, where you can do the forecast or event detection, like if there is there any fault in the system or not. Power quality assessment, like if there is any harmonics in the system or transient in the system, or sudden sag or swell in the power system, you can detect it with the application of AI. you can do the topology identification, which is very interesting areas for distribution system, because especially in Bangladesh case, we don't know where the loads are located in the power system, whether they are connected to the three-phase system or one-phase system. So by going through the smart metering system, you can find out the topology of a distribution system. And another application of AI that I just discussed a while ago, that when we are trying to solve the unit commitment problem or optimal power flow, it takes a long time because we have a huge amount of variables in the system. So there is research is going on whether can I use the historical data to speed up this optimal power flow solution. On the power system operation side, I would say that there is an application of deep reinforcement learning, like people are thinking about, though it is not applied directly in the practical side. Maybe in some part of China, there might be some practical application right now, but not directly in the real-time power system. But there is a huge interest is going on in the area of deep reinforcement learning to apply it in power system like asset management or demand response side or cybersecurity side. So let's come into the summary. So when generally when we talk about power system, we just consider some typical stuffs like huge generators or huge transmission lines or distribution system. But I showed you some scenarios that the power system, current trend of power system is changing. And to accommodate these changes, researcher needs to change the infrastructure of the power system for future smart grid. So application of optimization is a very small areas where people can consider to integrate this to get rid of these challenges and make the power system more smarter, cleaner, and sustainable. So the optimization area is basically a mixture of collaborative areas. So you can consider like software engineers, people from the areas of operation research, people who has background in mathematics, people who has background in electrical engineering. So everyone can collaborate in these areas to get a smarter, cleaner, and sustainable power system. So thank you, everyone. So and after that, I am going to return to Sajid.